Hey everyone, this will be the final video in this little orientation warping series. In it, I will replace the AnimNode plugin's orientation warping with my own control rig orientation warping system. Again, the project file will be linked in the description below. There's not much more to say, so let's get started. First and foremost, you need to ensure that you have the control rig plugin enabled in your project. Just search it up in the plugins window, enable it, and restart it with the prompt that will come up right down here in the corner. Once that's done and the engine has restarted, you can right-click in your content browser. Under animation, you can select control rig to create a control rig. Now I know a whole lot of you, myself included, aren't nearly as familiar with control rig as you are with animation blueprints inside of Unreal Engine. So one thing to keep in mind is that when you create a control rig asset, it's not tied to any specific skeleton. There's no way to select a skeleton. Instead, you just create the asset, name it, open it up, and then once it's open, you can click this import hierarchy button and select a skeletal mesh to import the hierarchy from. But all this does is import a bone hierarchy and then assign a preview mesh to it. So I could choose a different mesh that doesn't follow the mannequin skeleton, doesn't use the mannequin skeleton, but if the naming conventions were the same, it would still be applied to these bones in this A pose position. It's a super flexible system, and it's just something I wanted to go over briefly before I covered what I've already done inside of the control rig that I've already created before I've begun recording. So once you have your control rig, you're going to want to duplicate this code or just download the project. It's linked in the description, but I'm going to walk you guys through all of this and all of my logic behind it. So essentially, what this is doing is it's rotating the root bone to face the locomotion angle variable that we created in the last video, and then we are unrotating the spine so that the head ends up facing forward. But truthfully, we do this all at the same time in a single node. So there's no process here or order that these bones have to be rotated in. So the first thing you might notice here is that there's a lot of variables, and the reason for that is that I couldn't figure out how to get arrays to work well or at all inside of control rig. I couldn't bring them in as variables. Setting variables to be arrays didn't do anything, so I ended up just having to create a bunch of name variables for the bone names of the spine bones that we will be rotating. Another thing is that this My Blueprint tab, where we create variables inside of control rig, doesn't always open up with the control rig by default. To open it, you need to go to Window, and then click on My Blueprint right here. Now I created a float that was locomotion angle. It's our input. It's our main input to our orientation warping control rig. Then I created 5 spine bone name variables. You could create more or less. I built the system with 2 approaches in mind. The approach of being able to use 3 bones or 5 bones or even less, but the 2 main ways it's done with the mannequin skeleton are to use spine 1, spine 2, and spine 3, or to use spine 1, spine 2, spine 3, neck 1, and head. I personally prefer that option where we're rotating the neck and the head as well. I feel that it looks more natural, but I know a lot of people take the other approach, so I wanted to build this system so that it could handle both. Optimally, I'd do that with arrays, and I'd use a for each loop and plug in the name into a modify transform and do that in a loop for each of the bone names added to the array. But because we don't have access to arrays currently in control rig, or maybe I just couldn't find them, we're doing it another way. I used a modify transforms node. There's an expandable input inside this item to modify array, expand it down to the item, and you'll see a type and a name. We leave the type as bone, and we plug in our spine bone named variables into the name input for all 5 of these items. And then in this rotation, which is a quaternion, we plug in this bit of math here. We get the number of bones in use, which is another variable. So let's say we have 5 variables, but I just want to use 3. Spine 1, spine 2, and spine 3. Well, we need to know how much we need to rotate each bone so that the head faces forward. And if we're using a different amount of bones, then that rotation amount is going to be different because we're dividing it up amongst the bones. In this case, we're just doing an even division. We're dividing the amount we need to rotate by the amount of bones we are rotating, and that's the rotation per bone. But to do that, we need to know how many bones we are using. We can't use an index or an amount of items in an array, so instead you have to, in the control rig node, input an integer for how many of these bones you're making use of, whether it's 1, which would look horrible, but just for the sake of example, you can do any amount, 2, 3, 4, 5. You can have more variables, have 10 spine bones, although I'm not sure why you'd want to do that. I'm sure there's a case somewhere, even if it's completely improbable. Anyway, so what we're doing here is that we're getting our locomotion angle and our number of bones in use. We're converting that to a float. We're dividing our locomotion angle by that, and then we are plugging that into a from rotator node to turn it into quaternion that this modify transforms node can accept. Now, you'll notice that this is plugged into the X of the rotator because we're using the type additive local for our rotation for our coordinate space. And in the mannequin skeleton, the rotation on the x-axis is closest to rotation on the z global axis, at least for the spine, neck, and head bones. It might be different if you're using a different skeletal mesh, so be sure to double check that. So we're rotating the spine. We also need to rotate the root, and that comes with a 6th array item. I don't use a variable for this. I've just typed in root. Of course, you'd type in the name for your skeleton from your hierarchy if it's different, and if the root is named differently. Now, I just get the locomotion angle. This time, plug it into the z of a from rotator node and plug that into the rotation because the root is aligned with the global coordinate system, and z on the root is the same as x on the spine bones. Now, for each of these variables, I made sure that they were public and editable by clicking the closed eye so that it would be an open eye. And that is all of our control rig. Once you have all that, you can save it and close out of it and open up your animation blueprint. You can then take the control rig. You can then take the old orientation warping node that would be right here inside of this run state, delete it, and get a control rig node. You'd then select your control rig. In this case, it would be control rig orientation warping, and then you check use pin for all of the inputs. You plug in your locomotion angle variable, put in your spine bone names, and then tell it how many of the bone variables here you are using. Because if you only use 3, you wouldn't even need to type anything in, and no bones would rotate because there's no bones with that name. So you'd want to make sure you're dividing it by 3, so you're not, otherwise you would be rotating all the way. That really is all there is to it. I'll now give you guys a little example here to end the video. So as you can see, the results are remarkably similar, if not identical, to the previous video's result with its orientation warping system. the orientation warping node itself could be used separately from the blueprint system that I created in the last video, and it could be used with any other system to eliminate the need for using a custom plugin for orientation warping inside of Unreal Engine 4. Alright, I think I've run around enough here. Again, download the project, it's linked in the description, play around with it, do whatever you want, learn what you can from it, and I hope you guys found this useful, helpful in some manner, and I'll see you all in the next video. Hey everyone, I hope you enjoyed the video, I hope you found it useful or learned something from it. If you did, be sure to leave a like, subscribe to the channel, and join my Discord server. Thanks for watching, and I'll see you in the next video.